All right. Welcome everyone to the 2020 APEC Groundbreakers Virtual Tour by Apaco UC. This year, our event will be the biggest one ever done with 174 sessions, including normal sessions, workshops, and hands-on labs from 123 different speakers over 11 days. Also, it will cover sessions on 4 different languages. Please remember to register to as many sessions you can, and all sessions will be available to replay as many times as you want for 2 weeks after the initial session date and time. You can also interact with the speaker at any time during that 2 weeks by posting questions or comments directly in the playback session page. I would like to say thanks to our Oracle user groups and Java user groups that made this event possible, and also to our sponsors, Oracle Groundbreakers and CloudDB. Now for today's session, Zero-Shot Learning in Modern NLP by Andrej Baranovskij. Hopefully I pronounced your surname properly, Andrej.
Yeah, just Andrej. So it's not J. It's like soft.
It's a silent J.
Yeah.
That means it's Andrej Baranovskij.
Yeah, correct.
Fantastic. Please feel free to write questions at any time during this session and using the Q&A tab of the Zoom webinar, and the speaker will be answering them at the end of the session. If any issues during the presentation, please feel free to contact me at any time using the chat tab of the Zoom webinar. Just to make this more clear, questions for Andrej, please use the Q&A tab. Then Andrej will be answering all the questions at the end of the session. And if you have any technical issues, any problems, or want to talk anything regarding the conference, please use the chat to interact with me as the moderator. Now, without any more delays, I would like to leave you with this amazing session by Andrej Baranovskij. And Andrej, I will stop sharing my screen now, and you can start taking control and sharing your screen. I will put myself in mute to do not disturb.
Okay, let me share the screen. Okay, should be able to see the screen now. And
yes.
Yeah, let me start. Hello, good evening or good morning to everyone. My time is morning, your time is evening. And in this session, I would like to talk about something which is called zero-shot learning and natural language processing. Yeah, so this would be the topic. And yeah, just a quick introduction about myself. I have like 15 years experience working with Oracle development tools. Specifically, this would be like Oracle Forms, Oracle EDF, Apex, WebLogic Server, and so on. And for the past 3 years, additionally, while working with Oracle in parallel, I'm also working with machine learning and open source libraries. So now kind of getting experience and implementing different use cases in both Oracle and open source tools. And I'm Oracle Groundbreaker Ambassador from Oracle, and also I'm certified TensorFlow developer in machine learning. So let's jump directly into today's topic. What is actually zero-shot learning? So to say in simple words, zero-shot learning, it means that you you don't need to provide any training data for the model. So you just using model which was trained by someone else, using it out of the box, and without any training data, you can get results. And in our case, since we talk about language processing, it could be, for example, such use cases like sentiment analysis or like text classification and so on. So you may get a sentence and you may classify or detect the sentiment in the sentence out of the box without training your model. And in general, so Why this is important? Because it's usually it's very hard to collect data for the training, and especially if you would like to detect sentiments on text from online publications, from Twitter. So if you would try to build a model by yourself, you would spend a lot of time aggregating data, and then you would need manually to go through the data and label it by yourself. For example, if you talk about the basic task like positive or negative sentiment for Twitter messages, for example. So if you would like to build this data set by yourself, you would, for every tweet, you would need to go and decide by yourself if it's positive or negative. And again, maybe for you it would look like positive or negative, but for someone else it would be would have different opinion and so on. So then questions like that are coming, like if your labeling is correct or not. And luckily, we have language processing is a very popular field in machine learning. And from like 2018, we got new sort of library to process text, and new algorithm. It's called BERT, and the BERT actually provides high quality embeddings, and like it can translate every word to certain number. And if you have a sentence, then with BERT you can translate sentence to array of numbers, and every word would have a certain meaning there. And then with this array you could operate on this array, and you could compare, for example, two different sentences, how close they are to each other, or you could detect sentiment from the sentence based on this array of numbers and so on. And before BERT, LSTM neural networks were widely popular for text processing. They're still used now, but most of the cases would be implemented with BERT and transformers. The very strong advantage of BERT is also the fact that it's able to detect word meaning, because sometimes the same word could have different meanings depending on in which sentence this word is being used. And with BERT embedding, the same word in different sentences with different meaning would get different embedding, and this would allow to do more precise classification, for example, because you could also you could encode the word meaning. And with zero-shot learning is typically, this approach is implemented by a very popular open source library called Hugging Face, and my current demo will be actually based on Hugging Face API. And Hugging Face provides the model which was trained, and what you can do, you can just reuse this model in your use case, and you just provide the sentences, and it generates classification results. This zero-shot model is trained on public data from the internet, from the Wikipedia, from other open sources, and there are open sources of data, I mean, from the web, and there are models on Hugging Face library which are which were trained more specifically for some more specific domains, for finance, for example. And if your use case is covering a specific domain with some keywords from finance, for example, then you may try to use library which is optimized for that specific domain, like finance or so on. But in general, the base model is trained on public data from the web. And actually, I will not have too many slides, just very few. And the my main session will be focused on actual coding and on actual exercise. And I'll explain you step by step how the API works and how you could use it in your project if you would like to. Actually, if after the session you would like to read more in detail how the architecture is being designed for zero-shot learning, so you could go deep into that, and I have this blog post reference here, and where I describe in more detail the way it works, and also I refer to original paper where zero-shot learning is described. Another thing, all the source code that I'll show is being uploaded to Google Colab notebook, and it's available by that URL, so that after the session or during session together with me, you could go through the source code, and this source code will be accessible obviously after the session as well, so you could experiment afterwards too. And the same notebook is available on my GitHub, and you can download the source code from there as well. Okay, so now let's see. Let me jump to the source code, and I'm using Google Colab, and this is the short URL as well for the same Colab. And if let me see, I could send in chat if you'd like to open the same URL and run it together with me. So you can do this. You can just open Colab and in your notebook and run it the source code from there. So no need to install anything, just out of the box. And by the way, if you talk about Oracle infrastructure, so Oracle on top of Oracle Cloud infrastructure, you have access to Oracle Data Science Cloud, and Oracle Data Science Cloud is also the main thing of Data Science Cloud is they provide notebook, similar notebook environment as well. It's not Google Colab, obviously. It's based on open source Jupyter notebooks. But in Data Science Cloud, you could also open similar notebook environment and run the code in a very similar way. But at least for me, it's still convenient to use Google Colab, because if you go Google Colab, you can share the code easily with anyone. You could just upload the notebook and make it public, and then anyone can access it. In Oracle Data Science environment, it's also popular. It's also possible, this thing, but you would need to keep instance running. So I think with Oracle Data Science environment is good for production use cases, or when you are implementing some actual case and working within your team. While with Google Colab is quite good when you do experimentations, presentations, and so on. So like this one. So the first thing, I'll install transformers from Hugging Face library, because we'll use zero-shot model API based on transformers. And we'll do data scrapping from the internet, and I'm scrapping English results, because I'm using model which is base model, which is trained for English language only. If you would like to work with other languages, there is a separate model that's being trained for, like, I think 100 languages are being supported by another model. And by default, Google Colab comes with machine learning libraries support with many of them, but Hugging Face transformers, for example, is not being included out of the box into the Google Colab session, so you need to install it, but it just takes a few seconds. So you run inline pip Python command to install transformers, and we install also LangDetect library, and installation is done. And by the way, this option to switch between hardware accelerators, and I'm using for this session GPU accelerator because it's way faster to do classification. In this case, since I'm using large base model which was trained on huge set of data, this model is complex. So if I would like to do classification in batch for multiple sentences, using GPU is way faster than by using CPU by default in this case. Okay, so we installed the library. In the next step, we do some standard imports. One of them is we're importing pipeline from transformers, and pipeline is some sort of wrapper that helps to use transformers library in a way simpler way. So you don't need to write a lot of code. All the complexity is hidden inside the pipeline. And like in the next step here, we just specify which pipeline we would like to use. And then all the source, all the functionality is being loaded behind the scenes by the pipeline wrapper. And there are multiple pipelines, like the simplest one is just classification pipeline, which expects that you would provide some training data, train the model, and based on that, it will do classification. There are also text summarization pipelines where you provide a large article, for example, and it does it creates a summary of the article for you. Another pipeline I would think about is text generation, where you have a sentence and it may generate the last part of the sentence, or even in the middle of the sentence you could specify the placeholder and it could generate additional word, for example, in the middle of the sentence, like a text generation task. In this case, we use zero-shot learning, where we don't provide any training data, and for that purpose, we have zero-shot classification pipeline. And by default, this pipeline is based on it's running on CPU, but we can specify device 0, and this means that pipeline will run on GPU if GPU device is available. And since we in runtime we decided to use GPU, so out of the box GPU will be available. So I do execute this cell, and since this is a clean session, clean collab session, it needs to download the model, which was trained by Hugging Face, and then we are going to use this model for our tasks. And it's like 1.63 gigabytes, but the download runs very fast, so just in a few seconds we'll get it. And by the way, you are not limited to use out-of-the-box model only. There are ways to fine-tune the model. So, for example, you may have you would like to use this generic model, but you may have a small set of data that is specific to your use case, and you would like model to actually to react to this data during classification. So you can do fine-tuning, and you can take the model, base model, and using transfer learning approach, you can feed your data into the model and create another layer inside the model, so that model will be aware about the custom data. So next time it will do classification, it will take into account data that was actually used during fine-tuning, and this would allow model to be customized for your requirements as well. And okay, so we got the model. In the next step, here I have a helper function which does Google search query, and it extracts the top 100 results. Then it goes into every page, and it scrubs the text data. So it's actually gets paragraphs and text, and downloads this text, and out of this text we create a CSV file with records, and then we will be using those records to process them and to understand the sentiment, for example, what people are actually talking about. I'll not go through every step through in this function, and what it does, as I mentioned, just does web scraping, and using Python request library, it executes call to the Google search, gets the result, and then navigates to every page. And we also have a bit of logic here, and we do some basic garbage cleaning, but still some of the garbage which is fetched from the websites, still it goes to the final result set. And later I'll show you that with zero-shot model we can, there's a trick which would allow us to during classification step actually to clean up this garbage data and drop it, and so that we would not consider garbage data as our in our results. And here we do like a first level scrapping. So just when we navigate to the website from Google search, we just get data from there. If this Wikipedia was returned in a result set from Google, then we would also navigate to the reference links from the Wikipedia article. And this means we would get text, which is referred to the original Wikipedia article from the second level pages. But if there is no Wikipedia in the results set, then we don't do it. Okay, so that's all the helper codes, and and now what we do here in this step, we actually execute the query using the helper function for the scrapping. And the query we execute is like Oracle TikTok deal news. And we know that this query will generate quite a few results because this is the popular topic. So we could scrap some data, and then based on this data that we scrap, we will run with zero shot, we will run classification task to understand what is the topic distribution, what people are talking related to this query about Oracle and TikTok deal. Okay, so we do now exercise, and we scrap the data, and we'll go from the first 100 results from the Google search, and we see that this already happens. And this it actually, the way how Google search returns the results, the same way we do scrapping, so from the first to the last. Okay, so it will take maybe just 20 seconds. It should be quite fast. And while it runs, let me actually show you something that I was talking just a few moments ago about the blog post that I was referring to. So if you would, after the call, if you would like to get more details, so I have a blog post about the same topic. And there you can actually have the explanation as well for every step that I was describing. And this reference to original article from the Hugging Face, which actually explains how the zero shot is being implemented in a library. So this is the post here. So a lot of details. It's good to do a study, and it explains how the model works. And another thing, if I would go to Hugging Face website, you actually have option to go to the models, and then you get access to the library. So you get list of lots of models available here, and in the Hugging Face models library, any user actually who trains the model based on Hugging Face base model and fine tune it and create their own model, they can upload it to this library, and then anyone could use it. So there are a set of base models, and then there is a huge number of models that are created by the community. And if you talk about Oracle specifically, so on Oracle Data Science Cloud Platform, you can run actually this Hugging Face library without any issues, because Oracle Data Science Platform it's a Python environment, and you can include any external, any third-party library there, the same as you would do it in any other Python environment. Okay, the web scrapping is completed, so we see is done, and okay, it took this amount of time, very quick. And when the scrapping was done, it's actually results were saved in this Google Results CSV file over there. And this is where all the rows are being stored, and we can fetch and load results in memory using pandas library. And this helper function reads CSV, which out of the box it's reading CSV file structure, and it loads so-called pandas data frame. And pandas data frame is very handy data structure, because it actually resembles the table structure, and you have columns, you have rows, and you can operate with columns and you can operate with rows. There are a lot of the API is very rich of pandas library, and you can do lots of stuff and filtering, data extraction, sorting, and just you can do it in memory, everything there. So it's very powerful library. And okay, we got 1,469 rows. This means this many sentences or paragraphs we will have for the classification task. Okay, and then we can just print some of the sentences to see what was fetched, and we see there are sentences related to TikTok and Oracle, obviously, because this was the query. Some of the sentences are noise and garbage, for example, like this one. Probably it looks like it was some advertisement in the website and it was fetched. And other sentences look all right. They're quite good. And there are other type of sentences which like some JavaScript was fetched. Probably when scrapping was executing it from one of the diffs on HTML, it's extracted JavaScript code, which is should not be extracted. But the way how scrapping logic works, it doesn't take into account those specific cases, and it scraps all the text from HTML. And you could invest more time in making scrapping more sophisticated and trying to check if the text is actually not a basic sentence, but it's part of some coding, like and if it corresponds to JavaScript syntax, and maybe then you ignore it. But okay, this would work. But my point is that okay, let's say scrap the data as it is, and then with Hugging Face classification, we could classify this kind of cases and group them in a separate category, like advertisement and some other garbage text. Okay, so we got sentences, and now finally we come to the main thing, zero-shot learning. So this is where we will do classification. And in a loop, we iterate through all the sentences that were fetched. And we are using pipeline, our classifier pipeline, and this was defined here in the beginning. This is where classifier pipeline was defined from zero-shot classification model. And we pass a request to the classifier pipeline to classify every sentence from the loop. So we iterate through all the sentences and we classify each of the sentences. And then we have the option to provide also array of labels. And this is where the main power comes of zero-shot classification learning, is that you can provide any custom list of topics, basically, or labels, in other words. And then for this list of labels or topics, model will try to group or classify our sentence and assign probabilities. So it will try to detect for the given sentence where it belongs. Does it belong to politics, business, cloud, security, or it's advertisement? A completely unrelated topic from the first four. And the way it actually works quite well. And if the sentence is really advertisement and is not related to first four topics, then it will be classified as advertisement. And interesting that is able to classify this technical text where, for example, a fragment of JavaScript code was scrapped, and it's also able to classify it as advertisement because it doesn't actually relate in any way to the first four topics. And this is how we filter the garbage. And you, as a user, you're free to select any topics, and then you may select one set of topics, other set of topics, and you may run the query multiple times and see how classification is being calculated. And the main advantage that you don't need to have training data set, and you don't need to label your training data set to the given topics. You just use the set of topics and pass the sentence, and you get the results. This is why it's zero shot. Zero shot, it means you don't have any attempt to do training. So with zero training, you get the result. You can do classification. So then classifier pipeline, it returns the result, and result is structured into two arrays. So the first one is array of scores, and the second one is array of labels. So for every label, the array of labels will be ordered in from the top probability to the smallest probability, and then scores array is labeled in the same order as labels. So in the first position you get top probability, and then it goes down. So we got two arrays, and then here we just do some basic statistics, and for every sentence we check if probability for the given label is higher than 50% from the first position, then we assume that sentence belongs to this topic. And we obviously we don't check second and third positions, because we want to get, in this case, just like binary classification. We want to understand to which single topic our sentence belongs. Later, I'll show in the next step, I'll show that it's also possible to do multi-class classification, and it can calculate for the same sentence, it can calculate that it may belong to topic 1 with one probability, to topic 2 with another probability, and those probabilities will not be related to each other. While by default in binary classification, it classifies in a way that it tries to find the label which the most likely related to our sentence. It gets the highest probability, and then proportionally all other labels, they get lower probability. So by default in binary classification, all the topics, they dependent on each other, while with multi-class classification, topics are independent, and probability is calculated for each topic independently without looking what other topics are. Okay, now I'm actually started to execute this logic, and what it does, it goes now through every sentence from our data set, which was scrapped from the internet, through 1,469 sentences, and every sentence it tries to classify. Since we run on GPU, it would not take like too long. Should be it should be reasonable, just maybe 1 minute or so. And yeah, we see that we already see that since I'm printing out the results, we see that in the first position we get, for example, some topics like business security, and in some cases get high confidence, like 80%. Some get lower, like 50 or 60%. And then once it's done, we'll do some we'll show the chart, and we'll see which topic is the most popular. So this helps to understand, in our case, public information, and helps to detect public sentiment, like what people or newspapers are talking mostly about this Oracle TikTok deal. We could have any query, and then we would get results for another query as well. In general, this is I was using this Oracle TikTok deal just for the demonstration purpose, but we use this approach in the projects as well, and there are multiple use cases where we apply it. The most obvious one is related to support. So our customer gets quite a lot of complaints, for example, from their own customers. They produce certain they produce food products, and they get complaints from direct customers or from retail chains, and they need to react quickly to complaints, and depending they have certain layers like critical routing, for example, or urgent complaints. And if complaint is critical, then reaction should be quick, and they should sort out the problem. some of the complaints they don't require immediate action and can be classified as routing requests. Currently, they had business analysts or support analysts who were daily going through the requests that were coming into the system and trying to assign severity level manually to every request. And sometimes this can be questionable because it's for support analysts. It may look like it's not urgent, but it's really urgent, and it kind of depends. And then the wait time is increasing if the request is not processed on the right time. So it's really important to, in this case, to classify requests quickly. And we were using also a zero-shot model, fine-tuned, because it's not doesn't work to use default model to process complaints, because they have quite a lot of specifics, specific text to the business domain. And we're using history. We got a history data, like probably 30,000 rows of complaints from the past, which were already labeled to urgent, critical, or severe, for example. And we fine-tune base model with this custom data, and then we did some evaluations, and actually with the new data that was coming, and classification was quite accurate, probably around close to 85-90% accuracy with the data that was unseen during training. And this helped us to actually put this functionality to work, and help them to improve the complaints processing, and make it response quicker. So that was one use case. Another use case with zero-shot learning was for large consulting company, and they have requests from the customers, for example, to evaluate certain brand or certain service which is online, to evaluate how popular the service is and what people are talking on the internet, in the reviews, for example, or in Instagram or on Twitter, or in general on some other websites, what people are talking about the service, and what could be improved, for example. So what we do there, we do also web scraping based on a certain query, and then for all the results that we get, we construct topics, and we do topic clustering. So we group all the sentences that are related to each other into certain groups, and this allows to build basically different topics, right? And then within each topic, we would like to understand what is the sentiment in the topic, what people are actually talking, and then the analyst can provide labels, and then based on those labels, we execute classification task, and we provide probabilities. So we can, and this allows to understand for every topic how positive, for example, it is, how negative, or maybe if it's set of labels is more granular, it helps to understand what specifically people are talking online about this topic, and so on. And this helps in automatic way. It helps to build results which basically allows to understand how to improve the service, or how to improve the brand, and so on, instead of doing manual processing and going one by one for every sentence. So that was about the use cases. Okay, it's the processing runs probably should be completed very soon. It's actually completed just now. Okay, it's a good coincidence. It's completed, and we got this. This is the classification result, and I can print it out just for better readability. And we see we can display a chart as well. We can see that for this almost 1,500 results, the top topic is business, obviously, and the second one is security. So there are a lot of discussion about the security, and the third one is politics. It's also quite quite strong topic. And the cloud itself is not getting too many too many results. That's too many not too many sentences labeled with cloud. And it could be that business topic grabs a lot of cloud topics, because in general cloud and business, they kind of related, but probably some of the sentences are talking about cloud very specifically, then they're labeled with cloud. And there are advertisement, this is noise and garbage. So there are more than around 60 sentences that were actually classified as garbage, and they are not being used in those 4 topics. And then let's see, probably this one would not, multi-class classification probably would not complete in time, but okay, let me run it anyway. And as I mentioned before, with multi-class classification, every label, it gets independent score, independent probability. And this allows, for example, if the sentence is kind of related to business and to cloud, it would allow us to classify it for both topics instead of just picking business one. And this would allow in more detail sort of structure our results. And yeah, I'm also checking here if for any of the labels, if probability is more than 50%, then I'm counting it into the statistics. And it could be the case when one sentence could be counted for business and for cloud and for security, for example, so for all 3 topics, instead of just counting it for single class binary classification just for one topic. Just another way of classification. And to run this multi-class classification is basic. You just need to provide multi-class true flag for the classifier, and then it does multi-class classification for you. And let's see for some of the results from single class classification. For example, let's see, there are, for example, there are some sentences that are marked with 85%, it's politics. So this is, this sentence talks about China, US, Trump, presidency, and so on. So this was marked 85% as politics. Then this one, and this also about Trump and something blah, blah, blah. It's also 93% politics. Quite many politics. There is one about security, because probably national security law was directly mentioned, so it gets higher, 89% probability. There is another one, 93% security. It's talking about US data and splitting TikTok into separate company, and related to censorship and security worries. There's one about business, 64% and 12% security. For example, this one is talking about Oracle to be proposed as trusted technology provider. And in this sentence, there is no direct mention of business. There is no direct word business. Business is not directly mentioned in this sentence, but still the model was actually assigning a label business for this one, because probably because it's talking about proposing provider and company and operations, so decided that's probably business. Let's see, this the cloud topic is, it doesn't, okay, there's one with 83% gets for cloud, and it's talking about Oracle and moving to the cloud and so on. Okay, so we actually almost done. So let's see if there are any questions while multi-class classification runs. Okay, there is probably no questions, but in any case,
Andrej. Is no questions at the moment. Thank you, Babu, and the panelists that participated. We had a small issue from our side with the session when broadcasting. We forgot to take the password off to allow the people direct connected, and then we were told that they're being asked by passwords, and we made that public by Twitter and replay for the people that was also contacting us by email. And also that for the people that missed the first few minutes of the session because of this inconvenience, the playback of the session will be fully available in around 1 hour from now. And then you can also see the full session, and also in the page of that session, the playback page, you can make questions and comments to Andrej also, and he will be notified and he will be able to respond to any questions and posts on his convenience.
Yeah, sounds good. Yeah, I'll follow up. If there'll be any questions, we'll be happy to follow up, definitely.
Thank you so much, Andrej.
Okay, thank you, guys. So yeah, thanks, and enjoy the rest of the conference.
And have a wonderful day on your side, Andrej. And thank you so much for sharing your knowledge with the community.
Okay, thank you. Bye.
Bye-bye.